Okay guys, we're moving on now to a bit of a harder polynomial to graph. P of x is equal to x cubed plus 2 to the power of 2x to the power of 2 minus x minus 2. And now guys, I should draw your attention to the fact that the more powers there are, so we have 1, 2, 3 powers, the more times in which the curve can cut over the line. So the more roots there are. So this graph could cut over 1, 2, 3 different times. But we'll get to that a bit later. Right now, what we're going to do is we're going to, what? Factorize. That's right. Now, this one, x cubed plus 2x squared minus x minus 2. Where do we begin here? Well, we've got 4 terms. That's a bit of a hint. When we have 4 terms, there is a way that we can factorize. I'm going to grab the first 2 terms, x cubed and 2x squared, and I'm going to put the factor that they share out the front. So I'm going to put x squared out the front of x plus 2. And some of you see where it's coming to, maybe. Alright, so the next pair are minus x and minus 2. Now, just like I did in the last question, I can factorize minus x and minus 2 with minus, right, as x minus 2. Alright, so with this special type of factorization, I can factorize, make my first factor x squared minus 1, or squared, and x minus 2. Now, I am almost finished factorizing. There is just one more bit. You might notice this is a square. Now, whenever you see something that's a factor that's a square, you always need to think, is there something else that we can do? And in this case there is, because that's x squared. This is minus 1. However, it could also be called minus 1 squared. So it's a difference of 2 squares. So that factorizes once more to x minus 1, x plus 1, x minus 2. So, and I'm going to do this quickly. For the roots, otherwise known as the x-intercepts, otherwise known as the y-intercepts, known as the x-intercepts, when y is equal to 0, we have x is equal to. Now, because of this one, it's plus 1. Because of this one, it's minus 1. And because of this one, it's plus 2. So 1, minus 1, and 2. So we get 3 points, 1, 0. Minus 1, 0. And 2, 0. Now, it's pretty easy to plot those points, and I'll do them quickly. X is equal to 1, x is equal to 2, x is equal to minus 1. Alrighty, like I said guys, this could have crossed over 3 times, and it does. Now, the question is, does it come down like that, up and down and up again? Or does it come from the top here, down, then up, then out going down? And you can answer that question by thinking about the equation in terms of as x gets bigger, or as x approaches infinity, what does p of x approach? We look at this equation. This is the largest part, so this is what we're really focusing on. X cubed, as it gets bigger, well, as x gets bigger, x cubed gets bigger, and that's what matters. So p of x also approaches infinity. More importantly, it approaches positive infinity, which means, if I go back to my graph, the exit wound, as it were, is going to be coming up from there. So my graph is going to be going up and down like that. So just remember that. It's coming down from there. It's starting in this area. Alright, I'm going to go back over here because I need to do one little more piece of work. I need to find the y-intercept. Now the y-intercept occurs when x is at 0, and if I go and have a look at my graph, if x is 0, x cubed is 0, 2x squared is 0, minus x is 0, and all that's left is the minus 2. So if I go back over here, the y-intercept, p of x, is equal to minus 2. So I get the point 0, minus 2. So that's a little handy point down there. At 0, minus 2. Alright, so let's just make sure that works. Goes down there, up there. Oh no. What have I done wrong? Okay, let's go back to the start. I have the first line, x squared, x plus 2. Uh-oh. The first line, I made a mistake. X plus 2 minus x minus 2. Now, I've factorised this part here by minus 1. So this should be a plus 2 there, which means that that is plus 2, that is plus 2, that is minus 2 as a result, which means that my point here should be minus 2. And if I go over here, this is no longer a point, however this is. Alright, see if it works this time. Starting from here, going down through there, oh yes, up there and down there, okay. Now it works. From here, going down through there, up through there, down there, and bingo, all done. As you can see, it was a fair bit of work to do.